Hi friends, welcome. In this video I am going to talk about interest calculation. So I will talk about investment part as well as debt and loan part. Simple interest and compound interest in the investment part, and in the debt and loan part I will talk about repayment at the end and regular repayment of debt. And again here as well it will be based upon simple interest or compound interest. In the regular repayment case, it is based upon simple interest, compound interest and unpaid balance. So let's see one by one. So let's start with simple interest. So here R is interest rate in fraction per unit of time. So 20% per year becomes 0.2 per year. So 0.2 is interest as fraction. Since the unit is year, so it is 0.2 per year. So interest after 3 years will be 1000 times 0.2 times 3. Now let's take compound interest in the same way. So again after 3 years, so here we see that the compound interest, when everything is same, is more when compared with simple interest, because in the case of compound interest also earns interest along with the principal. Now let's take the case of regular repayment of loan. So at 0 you take up a loan and you pay it off in n equal installments. So take the first case where installment earns interest. So each installment is of same amount. Suppose the amount is E. So this first payment of E, which will be paid at the end of first month, will earn interest for n-1 time period. Similarly, second installment will earn interest for n-2 period, and same way it will keep on reducing by 1 and the final installment payment will not earn any interest. So if you add all the installments with their interest that they earn, it should all add up to the respective interest rate. Now the second case is where the unpaid balance earns the interest. So here also at each installment is of same amount, and with each installment the principal amount gets increased and the interest amount gets reduced, such that the last installment takes care of all the pending principal amount. So let's do the calculation. So if the installment earns simple interest, then so here again instead of using rate as percentage, we are using rate as fraction between two successive payments. So first installment earned interest for n-1 time period, and the second one earned interest for n-2 period, and we keep on doing it. So at the end it should be simple interest of the original principal amount. So if we simplify the equation, so the installment amount can be expressed by this formula. Now let's take the case of compound interest. So here the first installment earns compound interest for n-1 period. The second installment earns compound interest for n-2 period. So if we simplify the equation, we get this formula for installment amount. Now let's do the unpaid balance case. So here we start with principal P. It will earn interest at the rate of R, and we have to subtract the installment amount after first. So the remaining amount will be P times 1 plus R minus E. So that will act as a balance for the next installment, and we have to keep doing it until the remaining balance is 0. Now if we simplify the equation, so if you notice, it is exactly same as the compound interest case shown before. So let's recap the formula. Now let's take the debt and loan case. So here the first column is just a repeat of previous slide, which restates the formula for calculating the installment amount. Here K tells what fraction of the principal will be paid as the interest. Now in case of compound interest, it is easier to express the opposite of K, which is how many times of the principal will be paid as the interest. So now let's do some calculation for simple interest case and see different values of interest rate, what will be the duration in which half or 1/3 of the principal amount will be paid as interest. So here small r is the interest rate in percent and capital R is R by 1200, which is the fractional part per month. We have to make payment in n number of months. So with this substitution, if we work out the formula for n, we find that for K equal to 2, which means half of the principal will be paid in 2400 by R minus 3 months. So if R is 12%, then it will be 197 months. So if you pay off the entire loan in 197 months, then you will pay half of the principal as interest. Similarly, for K is equal to 3, for 1/3 principal, it is like 1200 by R minus 2. So if R is 12%, then N will be 1200 by 12, which is 100 minus 2, which is 98. So if you pay off the entire loan in 98 months, then you will pay 1/3 of the principal as interest. And so we can do for K is equal to 4 for 1/4 of the principal, and K is equal to 5 for 1/5 of the principal. Let's do the same exercise for compound interest. So it gives you some sense of the numbers for other interest rates as well. So let's do some questions. So here we have interest for second year and interest for third year. So between second and third year, the rate is going to be simple interest only, because it is a matter of only 1 year. So if you subtract the interest earned after 2 years from the interest after third year, we get what was earned in the third year. And since it is a compound interest, so the principal will earn interest and the interest earned till second year will also earn interest. So if we can break this number in such a way that the interest part and the principal part both have same rate of interest, then we can find out what our principal amount was. So here we say that 1456 minus 880, which is 576. Now 576 can be expressed as 176 plus 400. So 20% of 880 is 176. Then we have to find out, is there some number in the options whose 20% is 400, and we see that the answer is C. So we get C as the right answer here. So the amount becomes 16 times in 20 years with our compounded interest. So we follow the formula. So R is roughly 18%. So if we do it over 20 years as a simple interest, then interest becomes close to 3.6 times of the original principal amount. So here year number 0, then year number 1 and year number 2. So in case of simple interest, in the first year it earned 300 as interest, and in the second year again 300, so it becomes 600. So in case of compound interest, in the first year the interest earned will be same, and in the second year the principal will earn interest and the interest will also earn interest. So this interest in this 1 year duration has earned extra interest of 30, which is 10%, which means the rate of interest is 10%. So here we will use our formula to calculate installment amount. Now if we do the same thing for simple interest rate, so let's first calculate how much the shop earns with first scheme. So 20% discount, and on this amount it will earn 10% as compound interest for 3 years. Now in the second scheme, so down payment will earn compound interest of 10% for 3 years, then 3 installments of 3000 each. So second installment will earn compound interest for only 2 years, then only 1 year, and then no interest for the last installment. So the total amount is going to be which means that the second scheme is more profitable for the shop. This completes the video. I hope you liked it. Please share your comments, thoughts and other topics that you would like to see videos on. Thanks for watching. Please subscribe to my channel if you have not done so already, and please hit the like button and bell icon. Enjoy.